Raj, hello. Okay, no sound, huh? Thanks. Hmm.
Also unmute your mic.
Oh, yeah, good morning, everyone. Uh, I request someone if am I audible or not, please somebody can confirm.
Yes, you are audible.
Thanks. Thanks, because Philip, I was not able to get your voice from here. So this is a one-sided conversation. So I think let me start. So first of all, good morning to all global climate leaders, and thank you very much for this opportunity. So I'm Dr. Ishan Purohit, and I am a program specialist with the International Solar Alliance. And next few minutes, I will be uh, talking about streamlining solar success through harmonization of quality assurance measures for scalable impact. So, implementation of solar is not very new. We know that global market is very, cooperative for this one. We have very large capacity numbers. Just considering the case of India only, last 3 months, more than 25 gigawatt capacity has been added. In last 2 years, more than 1,000 gigawatt capacity global has been added. So big numbers are there, but if we see, uh, the penetration is not, I will say, uniform across the globe. And there are several challenges which still countries are facing. So few are them, especially when we are talking about bankability. Quality assurance measures is one of the key aspect. So ISA is trying to address this challenge, especially for global South countries. So the way we see this entire segment is solar energy technologies. The uniqueness of technologies is basically the range of solutions which solar energy gives, none of another technology gives. It can give you from milliwatt to gigawatt type of capacity, and very small requirement of energy to very large. And nowadays people are talking about firm and dispatchable, so very comparable with the thermal or conventional source of energy. And its components or associated technologies are, for example, we are talking about the battery storage. Again, it is giving you solutions from some milliwatt hours to some gigawatt hours. So this is basically the big range of technology. Or application wise, if we see that the conversion efficiencies are around 10 to 25%, and if we do jugglery, so up to 40 to 50% with hybrid we can achieve. Similarly with solar thermal technologies, if we believe on fundamental heat transfer, so we can achieve temperature of sun through solar energy collectors. So there are a lot of technologies which are very much suitable for medium process to, in fact, the high temperature applications up to power generation and industrial process heat. And in this segment, the efficiency is pretty high because it is the thermal conversation of solar radiation. So this one side, it is very attractive that we are actually able to, address almost every type of applications which human beings are looking. But other side, if we are looking from financial feasibility of the technology, so all technologies are actually not financial feasible, and different type of challenges are there. So that's why quality control measures are very essential, because investors or the customer need insurance on the return on equity or return on investment. So because solar energy is intermittent in the nature, there is a fundamental equation. If we are talking in terms of energy, so it is radiation into area into conversion efficiency, and very simple physics is there. Efficiency could be guaranteed by manufacturer. In fact, area could be guaranteed by manufacturer and what type of application we are doing, but we cannot guarantee incident solar radiation. And that's why the performance prediction, especially in terms of safety, reliability, and promised performance. For example, I am doing a project where I am taking some assumptions on CapEx, OpEx, technical output, CUF of the plant, and operation and maintenance aspects. So if it is not repeatable, my project will be certainly in the risk. So that's why heavily we need to rely on the what type of quality control measures. I am not categorically saying is the quality standards directly, because some technologies are very advanced and some are emerging. And in case of solar energy, we are having a technology and we are having an application. Same solar PV module could be used for a power plant, and same could be used for a supplying power through battery storage to some telecom tower or some water pumping application. So all these type of systems follow different type of aspects, and the quality control measures varies. So the way ISA is looking on this one is, we are approaching and we are following a two-dimensional approach and considering across the globe whether is it possible to consider a single performance standard across the globe, considering all type of climatic conditions, and how to implement. So one side, we are working on developing a global quality manual, which will be comprising all sorts of technologies which are existing and commercially available or in the path of commercialization. And it will be through either IEC, ISO, ASHRAE, country-specific standards like BIS, UL, those type of standards we will be compiling. We will be coming out with a global quality manual, and then these manual need to be adopted by the countries. So with ISA member countries, we will be working on the implementation or institutional arrangements for implementing and following up these standards. Once it is done, then any country, whether it is making within the country the manufacturing is done or they are importing, they can follow a process of testing and certification, and that could be adopted by member countries. Just giving a case of India specifically. So in country, if you see the way it is structured, it is not basically technical aspects, but we need to think from implementation and institutional arrangement for this one. So there are research laboratories and research institutions which do research, and those research are converges in form of test standards, and then adopted sometime in-house by IEC, ISO, BIS, UL, and they come out with basically the standards which need to be adopted by the country. Then there are agencies, for example, again in India, if we are looking for implementing a large scale solar power plant or any solar technology, there need to be there is a mandatory condition to have certification from Bureau of Indian Standard. And Bureau of Indian Standard is institution, it is not a lab. They actually approach national, this is NABL, this is the Quality Assurance Institution, which actually take care of identification of suitable laboratories or test centers and authorized or make sure that they are able to do these type of testings. For example, IEC 61215 is for crystalline modules of silicon, and it is tested by NABL and BIS accredited laboratory. For example, there is National Institute of Solar Energy, there is TUV, there are more than 10 such type of laboratories existing in India. Once they are certifying it, then only project developer or whosoever is putting project at any location, they will get clearance for implementation of the project. So all technology, as I mentioned, are not on same platform. For some technologies, there are standards available. For some technologies which are emerging, because this is emerging area, every week you can see new model is coming, new battery is coming to the market. So specification are changing. So there are codes and there are minimum functional specification as well. So our intervention on quality assurance manual will be taking care of all, basically compiling the global research through standards, then developing codes and adoption of the best practices, and how to replicate in ISA member countries. So this approach we are actually following. So ISA will develop a global quality assurance manual for solar technologies and systems. So whatever type of system, whether thermal, whether PV type of system, off-grid, on-grid, any type of solutions which is available and available in the market, somebody can provide this technology to users. Then we will be working with the countries to develop their institutional mechanism. For example, any member country where we are working with, they will nominate an institution. Our manual will be given to him, and then we are having our solar technology application centers in various countries. In 12 countries, we are operational, and we are targeting around 50 such type of centers will be there by year of 2030. So all these test centers, these are right now, these are our training centers, but we are planning to basically enhance them to conduct testing and certification. So our star centers will be having this quality manual and make sure that the country who is looking for implementation and testing services, they will be going to star C. Some tests they can do, and otherwise they can approach ISA's new intervention called Global Capability Center, which is backed by IEC approved laboratories or NABL approved laboratories. For example, we are closely working with National Institute of Solar Energy. Just an example, if a country like Senegal, they approach our star C that, okay, they need a testing certification or testing services or quality assurance for a product. Our star C will approach our GCC, and GCC will make sure that, okay, NICE or similar type of institution is giving that services and making sure that the product is qualified or non-qualified as per the IEC or as per the applicable test standard in the country. So for this, we will be having a detailed plan for implementation. Through Star C, we will be doing the capacity building or the strengthening of the laboratories, and it will be developed through our GCC, regional and international collaboration. So I will stop here, and this is basically on prima facie ISA's plan for testing and standardization of solar energy technology and systems, and which will be implemented through our GCC, backed by our Star C. So I will stop here, and if any question, I will be happy to take. Thanks, Felipe.
Thank you very much, Ishan, Dr. Ishan. for addressing the quality control measures for solar technologies and the role of the Global Capability Center and StarSys in this context. Now we will start our panel discussion with our distinguished panelists, in which I will introduce. So with us here, we have Mr. Vishal Mahendru, Vice President of International Electrotechnical Commission, IEC. Mr. Jonas Moberg, CEO, Green Hydrogen Organization from Geneva. Online, we have Professor Ishan Marius Petter, Group Lead, Fortune Gristrum Julich. I don't know if I pronounced this German words correctly, but I let you, Ian, to correct me. Dr. Birich Bora, Director Technical from the National Institute of Solar Energy in India. Both the three are online. And I will hand over to our honorable moderator, Dr. Ajay Mathur. Dr. Ajay Mathur is the professor of praxis in the School of Public Policy in India Institute of Technology of Delhi. It's an honor, Dr. Mathur, to receive you as a moderator in this session. And I hand over to you to moderate our session to our distinguished guests. Thank you very much.
Thank you. To repeat, I am delighted to be the moderator of this session. We have a wonderful panel: Vimal, Jonas, Ian, and Birinichi. Ian and Birinichi are online, but I look forward to them participating in the discussion. All of them have been friends for many years, and I look forward to this discussion. So let me start with Vimal. Vimal, you heard Ishan talking of the global capability centers and the star centers. And my question to you is, both as a person who was one of the first movers on the electronics in the electrical industry in India, and now Vice President of the IEC, and particularly since you are looking at the small and medium sector, what is it that you see IEC and the ISA collaboration achieving? In particular, can the IEC support the various star centers that are set up by the ISA?
Thank you, Dr. Mathur. First of all, it's a privilege to be here sitting next to you. We've known each other for several decades. And so this is like coming home for me. A quick answer to your question: overwhelmingly, yes, there is a lot we can do together. Let me go back into the DNA of IEC. IEC has been around for 120 years, but we are a bunch of engineers, geekish solutions based on the problems that come to us. Over the last 120 years, we've done standards for electricity, electronics, and software. And I can assure you 99% or nearing 100% of electricity you see around us comes to you through standards written by the IEC. That we have is, as newer technologies are coming in, solar PV, especially in the last 30, 35 years, even though we have written standards, the standards are only as good as the information we receive and the people who are sitting in the room to write those standards. If we don't understand what is happening in some communities, some countries, some remote places, just because they were not in the room, or those who were in the room did not know what's happening in those outlying places, then the answer that we would have is incomplete. So one of the biggest things which I would really welcome ISA doing is telling us more about the on-ground situation, which ISA is so familiar with. IEC, based in Geneva, I must honestly confess, we do great standards, only limited to what we hear from the people who come. But for those who are not present, that's where we have a problem. And this is especially true with the global south. Many of the members of ISA are not actively involved. So if I can leave one message for all the ISA member states, please, please, please bring your paradigms, your challenges, your implementation issues on ground. And I can promise you, we will write standards that are really meaningful for you.
So I want to ask you a particular question, which has to do, the vast number of our member countries have what are called the small and medium enterprises. And what are the challenges in implementing standards in the small and medium enterprises? The fact that you are the special envoy speaks of the fact that you need a special outreach for them. Would you be able to provide us a background of the kinds of challenges that you face?
My own background is that I come from a small and medium enterprise in India, and it was started by my father when we were a small fledgling company. And so I can share even my own experience. The biggest challenge was we didn't have enough money. So how do you fund your growth, your innovation, your new products? And so we were always, if I go back 40 years into my career, we never had enough money for anything. And then trying to be innovative, I think that was a challenge. The good thing today is, and for anyone who's in the SME sector today, I can promise you capital is far more easily available today than it was ever in the past. So capital is no longer the issue. The real issue is for SME sectors, which we are trying to bridge. We don't know the real answer, or we've not hit it upon the head yet, is what are the core technologies that you invest in? Let's talk about standards, the domain we come from. IEC standards are written because in a way that there are about 173 member countries. And from those countries, whatever information we receive, we write those standards. However, some of the SMEs I have noted, especially in some developing economies, they may not have access to the latest standards. They may receive standards from some grant coming from a specific country, and those would be standards which are specific to an individual country or a manufacturer. Now, they may get a good deal on those solar panels or equipment, but is it the real thing and the right thing for the future? Does it address the local needs? Is it addressing the climate and the operating conditions of the country where the SME is trying to operate? We don't know. So one of the things I think the challenges that the SME sector faces is, are they looking at the right technologies to invest in, work with? I think, and that's where knowledge of standards domain, I think Ishan showed on one of the slides, multiple organizations which are writing standards. Now you have to be careful which standards you are adopting for the technologies so that they work for you. Based on that, which testing parameters are you using? That are those really addressing the operating conditions in your country or the place where you're installing that equipment? So I think those are some of the things. The third, which is closer to my heart, and I think another thing which we can do with the Star Seed program is capacity building. I mean, we keep talking about capacity building, and I don't think there is ever going to be an end to capacity building where we say we've done enough, no more. I think this is an evolving story. You know, the more capacity you have, the better is the implementation, and you can keep improving the systems, the processes, efficiency, because this whole thing is a long-term delivery. It's not a short-term project that you are installing a solar panel one time and you are out of it. You have to deliver value for the next 20 to 25 years. That's when you really get the benefit. So capacity building for almost understanding and delivering value for the whole life of the installation that you are installing.
Thank you very much. You know, it also brings in, Jonas, a personal perspective. I remember in the Bureau of Energy Efficiency, when we tried to put in standards, one of the challenge was, what standards do we adopt? And believe you me, the biggest problem was in how is the testing done? And I'm going to come to you, Jonas, on it. One of the issues that happened with testing was that at that point of time, there was no testing standard for refrigerators in India. And therefore, we adopted the New Zealand standard. We also adopted the New Zealand standard for air conditioners, just made life easier. But over a period of time, two things happened. One is more labs came up. Initially, there was one lab, but more labs came up. But the second thing was we realized that the standard testing, not the standards, but the standards testing had to be Indianized. So we developed something called an India Seasonal Energy Efficiency Ratio, and the testing to be done so that the ISEER, as it was called, could be tested. And I'm wondering if we are moving towards the same kind of local climate-based interventions as far as solar panels also are concerned. But Jonas, let me turn to you. You are the CEO of the World Green Hydrogen Organization. And let me ask you, what are the kind of quality control measures that you consider are absolutely essential? First, to take off, for the world hydrogen system to take off, and then where is it that we need the tweaking so that these can make sense to the countries themselves?
Well, thank you very much. You're doing an admirable job with background noise, and I'm deeply impressed by everyone. Look, let's first establish the link between solar standards and green hydrogen, green molecules. Of course, you do not have electrolysis. You don't produce green hydrogen, green ammonia, whatever, without renewable energy. So you need solar and wind, hydropower, maybe geothermal. Huh? So now, of course, what we're hearing at every other panel here is, of course, the miracle now, the electrotech revolution, the incredible building out of solar, together with storage. And I will come back to that, the important part of the story. Now, fundamental challenges we have at the moment is that while that is amazing, the building out of renewable power, of renewable electrons, we are fundamentally struggling, let's be honest, about turning those electrons into green molecules. Outside China, to some extent in India itself, one or two other places, we are not able to compete with oil and gas alternatives. We're not able to compete yet. Costs are coming down, but they need to come down further. It's one of the many things that needs to happen. And that, of course, is part of having good standards. Now, one of the magics, of course, is this combo, as I said, and I want to come back to, of solar with storage, short-term storage, even sometimes as short as 2 hours or 6, possibly even up to 8. Now, if we look at in many parts of the world, we are increasingly doing solar and storage integrated together. And that's obviously a hugely welcome development. But coming to your point, Ajay, we need to be much, much faster on the government side, on the utility side, in terms of adapting the kinds of PPAs that we are having. So how are we contracting this? So where I'm coming from to this, to a large extent, is we need to do a much greater work working together, adapting to integrated systems. And there is, of course, a third component that you've already mentioned. We got solar integrated with short-term storage, and then O&M. We have far too many projects around the world that have never been in operation or that are white elephants. We know it. And we didn't get a lot of things right. And part of it was standards, but a lot of it was also because we did not think sufficiently about operations and maintenance. Now, there is a latest generation of PPAs. So when we sell these systems to utilities, to governments, where we have the integration of solar with storage and operation and management for 5, maybe even as far up as to 10 years. So I think we need to work a lot more closely together across governments, making sure that the PPAs, the way we set our RFPs, the way we invite developers to bid, is not just about standards, the technical standards for the PVs and so on, but that factors the latest developments here in. That is going to ensure that we get cheaper systems that we actually look after and that works.
Jonas, this leads me to the question, what are the standards that you consider to be for green hydrogen development? The key standards that you see that need to be in place for the system to go ahead. You talked of the power purchase agreements. Yes, of course. But quality assurance, what are the kinds of issues that we need to make sure? You talked of O&M, but the O&M will be according to the kinds of practices that the manufacturers ask. And the manufacturers will produce according to the standards.
Yeah, I mean, Ajay, it's almost impossible unless you tell the standards we're thinking about. Because on the technical side, we're seeing a lot of developments. And as I've started the meeting, we got to ensure that those standards are neutral in terms of the competition, particularly now between Europe and China. Those are the two markets that we are now struggling to figure out how we create a level playing field. But Ajay, I come back to my earlier point. It's much more than technical standards. One of the key areas of standards when it comes to electrolysis is actually what kind of power are we talking about? Are we talking about how do you define your renewable energy? And of course, that, whether we accept so-called monthly matching or whether we require monthly matching, that will in turn is having an absolutely essential on the kind of electrolysis systems are going for. So everything is, at the end of the day, there are a number of different variables where the standards are key. Just technical one. It is also the rules for the renewable energy. And last point, when it comes to that, it's a little bit hard to ask countries opt for the same. because countries will naturally opt for renewable energy standards that are suitable to the energy mix, energy potential, energy potential have. Yet uniformity is very important, but we also got to remember that we have to have standards that will diverge a little bit, and we need to a degree of flexibility in systems.
Can I just make I just want to make a quick comment to a point you made earlier on it's not just about technical standards. And when I talk about especially solar PV implementation, my personal experience is that technical standards, performance standards, efficiency standards, material standards, etc., are all there. What we are really missing in several projects we've seen worldwide, especially in the global south, is the complete O&M package or thinking around how you use technical standards for delivering value. I have actually visited sites in some countries which are, for the lack of a better phrase, known as solar graveyards. Reason is that you would see on top of a primary school in a village or a medical center, 3 or 4 different sets of solar panels. Funding agencies are very happy to fund, solarization or providing lighting and basic electricity in the schools and medical centers. But in less than a year or 2 years, they just fail. Why do they fail? Because the parameters set by the funding agencies or by the implementing agencies was go there, install, make sure it works, and then you get paid. And they don't care about whether the installation is robust enough and it will live for a long time, whether the maintenance of those is, there is a trained team nearby, or even the people who are benefiting from it are trained enough to think of basic issues that could come in and do some preventive maintenance on their own. And so this leads to, I have myself seen 3 or 4 different solar set panels funded by global players, and they're very happy to show it in their annual reports that we funded 10,000 schools in this country. But none of those schools is happy because the panels just failed. The first time there was a hurricane, the panel just flipped. What happens then? And then the technology gets blamed. So I think we need to start looking at some of these things in a holistic manner, not just technical standards.
Thank you. Thank you very, very much. I mean, that was very useful, because what it tells us is that, as you've rightly said, skilling is part of the entire process of setting up the solar plants. So, Ian, we had a discussion yesterday, and we focused, I mean, at least I focused, and so did you, on the needs for standards. Now, you talk of tomorrow's standards. So obviously we are looking at performance. We're also looking, what it tells us, we're also looking at reliability. What are the kinds of standards that help in both performance and reliability from your point of view?
All right, thank you very much for the question, and also thank you again for having me on this panel. It is a great pleasure and a great honor to be here. I'll answer this by giving you some examples. So I'm coming from solar cell research. I'm working with IEC standards actually every day, and let me cite to you one that I think has done a tremendous job and is doing exactly what the standard should do. This is the IEC 60904, which is telling us how we should be measuring a solar cell. And I think this is a wonderful standard because every lab and every manufacturer in the world is using it, and it allows us to compare results for solar cells across labs from anywhere, and it allows us to compete with each other. It allows us to learn from each other. So this standard solar development has been incredibly dynamical, and I think this standard has been one to support it, right? Having this metric, the efficiency, and having an agreed upon way to measure it has been incredibly valuable for us. So this is a standard that does exactly what it should do. Similar standards apply for measuring the reliability of panels. Now, here we have a challenge because we're going to new technologies, for example, perovskite technology. And because perovskite's upcoming solar cell material is degrading and aging in a different way than silicon does, if we apply the exact same standard to this cell, we are getting results that would, for example, investors scare off from developing this material further. And in that case, the standard can do harm. Fortunately, of course, there are efforts in place to improve those standards in order to measure the material in a way that makes sense. So this is the concern that we always have with standards if you're coming from a researcher side, right? Standards cannot inhibit on the improvement, on the innovation that we are doing in solar. I give you an example of that one, for example. People that are working in solar fields are always saying it would be fantastic if we would be able to switch solar panels. So if I can take one solar panel off and put another one in. And that today is difficult because solar panels are different, right? If I buy a solar panel today, it will be different from the one that was 10 years ago. But it doesn't make sense to say we lock a solar panel onto a certain size and onto a certain power because it would immediately prevent us from innovating on these aspects. So the industry needs the freedom in order to develop this. And sometimes this goes against interoperability and exchangeability. So here a standard doesn't make sense. And there is also no standard for this. And it's good that there is none. A third example I want to give where we're missing standard is we've been getting into this is the combination with battery and solar systems. So electric vehicles, to integrate electric vehicles into home systems, that has tremendous potential, but it is currently difficult because to some extent of a lack of regulation and to some extent of a lack of standards that allow to interchange between different battery system, connector system, and solar system. So here is an area where we need standards. So just to summarize this, standards can do a fantastic job if they're done well. And I think the IEC has done a fantastic job. So thank you for the ones that we are having there. And we need more of those in order to really keep the dynamic development there. And we don't need standards where it would inhibit that.
So Ian, let me, this follows up on if you're talking of emerging technologies, and this is something, Jonas, you spoke about as well. If you're talking of emerging technologies, you're talking of, in a sense, developing new standards. This obviously means that there is interdisciplinary cooperation between, on the one side, the technical part of it, which you mentioned, but also the social part of it, the interoperability that you talked about. So how do you enable this interdisciplinary cooperation in the standard setting as it is? Maybe you would like to answer this as well.
This is a fantastic question. I'll try to keep it brief. Coming from research side, I can give you examples for how this is working out well. And this is if we have interdisciplinary research projects that allow to set up kind of lighthouse projects, first exemplary kind of playgrounds, testing systems, where we try to set up these new kind of systems, for example, on the combination of solar, battery, hydrogen, and vehicles, right? We need to set up a first infrastructure, build it up to see how it works. And from that, we learn, we get the data that we need in order to write sensible standards. And then normally in a good project, there is already a part integrated where people are thinking of standards and are communicating with the communities and with the bodies that are writing these standards in order to develop them. I think this is a good way to do this.
So I just want to add to this, Ian, thank you very much for talking about interoperability. One of the things that we have realized in IEC is, while being a 120-year-old organization is a good thing, but it's also a bad thing in some ways. One is that we carry a lot of legacy systems, processes, and structures with us. One of those legacies is the technical committee structure we have. So we are vertically oriented in our structure for writing standards, which are vertical around products. But interoperability really needs you to break those silos and talk between various silos. How do we enable that? So over the last 10 years, we've been working on what is known as systems committees. Systems committees recognize at their very heart that a product is not used in its isolation anywhere. Solar PV panels by themselves don't mean anything unless they are connected through wires, through switches, circuit breakers, batteries to some consumption devices. So it's a system that works together. The IEC set up a system committee called System Committee for Direct Current in 2017, which is looking at the systems aspects around this. In my personal view, in the coming times, we will see that while there will be need for product-related DCs like solar PV panels and switches and circuit breakers, wires, cables across the board, but there will be an overarching need for interoperability, coordination, synchronization of work, performance, and data. Data is becoming more important in managing these systems. And so I think the future will see a lot more systems work and system level standards coming from IEC. Hopefully that will address some of the issues, Ian, that you mentioned.
Thank you for that. I think it will. Just let me say that it's also really, really important as we are going to larger and larger integration of renewable technologies. This interoperability, these kind of standards that you just talked about become more and more important in order to enable really carbon-free electricity systems. So thanks.
Thanks very much, Ian. Birinji, can I ask you, how have you handled this in India at the National Institute of Solar Energy? Because solar is clearly an emerging area. How have testing standards kept in sync with the kinds of changes that have occurred on the solar technology side?
Yeah, thank you, Dr. Mathur, for having me in this particular forum. So regarding this, actually, first of all, we are working for the component level testing. Like so, for PV power plant, we are going for testing of PV module, inverter, batteries, and other balance of systems. Other than that, component testing, we are also working regarding the installation and commissioning part. Suppose if I install a PV power plant, and after that, what is the effect during the installation by different personnels that we need to check, like we used to do the EL imaging after the installation so that we can check the quality of the module after installation. Then also we are working for the performance monitoring of the PV power plant in the real world conditions with respect to different climatic conditions. What is the effect on the performance in terms of safety as well as reliability part? And right now, we are also working for the development of standards for PV power plant rating. Like right now, there is no IC or any IC standards exist for the PV power plant rating, where we can say that this is the rating of the power plant and this will give more energy output. So that's why these type of standards right now we are trying to develop.
So, Birinji, your question, which may seem unfair, but makes other developing countries. How do you see the applicability of the existing standards? In a sense, you've already answered it, but how do you see the application of the current existing standards for other ISA member countries?
Like in some of the ISA member countries, their environmental conditions are almost like India. In India, we have around 6 climatic zones where we have temperature ranges from -40 to 50. So also our humidity level is quite high. So in that case, in most of the ISA countries, we have seen that we are in the same climatic conditions. So that's why in some of the standards where we are developing that how local climate can affect the performance as well as reliability in terms of long-term effect. So that's why in some of the cases, like I'm just talking about PV module like IC 61215 or IC 61720, which is adopted by the Bureau of Indian Standard, which is perfectly working in India and Indian climatic conditions. So that's why I can say that these standards will also work properly for that IC member countries where climatic conditions are almost similar to us.
So thank you very much, Birinchi. I think we are coming to the close of the time, so I'm not going to extend this any further, but let me ask you, the audience, if there are questions. I would be delighted if you can raise up your hands, and so it'll help me merge the questions and manage the time. Yes, go ahead.
Hello. So it's obviously very important to have strong governmental supports to expand the use of solar system, right? So I would like to know what are the main barriers that member countries face when trying to scale up solar projects?
This is a question that can take several hours, but what I try to do is to answer it in a minute. The key challenge, as far as you would have heard in this discussion, is that the situation in each country is different. The other is that you've also got solar panels being imported from different manufacturers. But a third issue that was raised here was the interconnection of the PV panels with the batteries, with the hydrogen electrolyzers. It is there that we see the greatest problems occurring. So obviously, as far as Philippe was concerned, he talked about the creation of the star centers, which address these issues, and looking at organizations like the Green Hydrogen Organizations and the IEC, together with the experience of organizations like NICE and the technology development like that of ULIC to help us move ahead. Now, this is easier said than done. What we would need is the local capability, the local capacity to be able to move ahead. And this is as much on the systems development and standard setting side as it is on the applications, operation and maintenance side, as was so eloquently pointed out by Jonas. So it's a short answer to a very short question. Let me thank the panelists. Let me thank Vimal. Let me thank Jonas. Let me thank Ian. Let me thank Birinchi for this excellent discussion that we had. It turned out to be a lot more cooperative than we had initially thought it would be. I also want to thank each one of you for being here, and you particularly for asking one of the key questions that continues to bother us as we go ahead. So many thanks, and I look forward to seeing all of you very soon. And Philippe and Ishan, many thanks for making this happen.
And hello. And a very warm thank you for all of you, panelists, Dr. Mathur, and audience as well. We are on time to close, but I will invite Dr. Miridula to give a few words for the closing remarks. Thank you.
Ladies and gentlemen, as we draw this insightful session to a close, it's my honor and privilege to deliver the vote of thanks on behalf of International Solar Alliance. First and foremost, I extend my heartfelt gratitude to our distinguished moderator, Ajay sir, and panelists who have enriched today's dialogue with their expertise and vision. Philip, thank you for setting the context, and thank you, Ishan, for presenting the overall picture of ISA's vision for addressing quality control measures of solar technologies through the GCC, backed by existing STAR-C centers in our member countries. Thanks, everyone. And the session has underscored the critical role of harmonized standards, robust testing frameworks, and collaborative mechanisms in building resilient and investor-ready solar ecosystems. The GCC and STAR-C initiative stand as beacons of ISA's commitment to quality, sustainability, and innovation. Thank you again, all participants online and in person, policymakers, developers, investors, and our collaborators for your engagement and continued support to ISA. Together, we are laying the foundation for a future-ready clean energy economy. Thank you. We close the session now. Wish you all a great day ahead. Thanks a lot.
Our panel is online. If you can keep in the screen just for 1 minute for her group photography, and you will.
Hello.
Good afternoon, everyone, and welcome to the third Sunny Side Up series at the ISA Pavilion. Today, we are delighted to have Professor Francesco Corvaro, the Special Envoy for Climate Change from the government of Italy, join us here. Professor Corvaro serves as Italy's Special Envoy for Climate Change, representing the country in global climate negotiations and multilateral forums. A full professor of thermal science at the Università Politecnica de Marche. His expertise spans across RE systems, sustainable technologies, climate mitigation strategies, focuses on bridging science, policy, and diplomacy, and works to advance Italy's commitment under the Paris Agreement and the UN 2030 agenda. Ladies and gentlemen, let's bring our hands together to welcome Professor Corvaro. Is the translation on? Professor Corvaro, I'm delighted to have you here at the Sunny Side Up series. This is a series that we keep conversational and anecdotal. And this year, as we celebrate the 10 years of the Paris Agreement, the world, finds itself at a turning point, and no longer debating if ambition is necessary, but it's about how to make it real, inclusive, and transformative. Italy has played a pivotal role in advancing this global agenda through the EU Green Deal and the recent submission of its updated NDC. I think reinforces the bloc's long-term commitment towards climate change. As we are 10 years old from the Paris Agreement, and ISA was born out of the Paris Agreement too, I would want to pose my first question to you, that what is the next frontier for climate leadership? While EU's updated NDC reflects both high mitigation and strategic foresight, from your perspective, how do such forward-looking targets influence global climate diplomacy, and what role can Italy play in ensuring that these commitments translate onto real action? Sir.
So first of all, it is a real pleasure, not only to be here because ISA for us is a great partner, but also because there is the air conditioning. This, first of all, is really good. So I had the honor to participate to your event in New Delhi, and it is for me really a good experience, and it is a real honor that Italy decided to be part of this adventure. Yes, we are 10 years from the Paris Agreement, and I believe that we have to improve something. Right now is the good time. First of all, we have to transmit a message. The energy transition is a great opportunity, particularly in job creation for the younger generation. We need new capabilities to perform the renewable energy, because renewable energies is not only to install a panel. It's not just this, but we need to rebuild, rethink all this grid that is necessary to improve the energy production and electricity. Because, by the way, in the next year, we will need a huge amount of electricity for a lot of reasons, not only for the air conditioning, but moreover for the artificial intelligence, cloud, data center, and so on. So on one side, we are asking for more energy. On the other side, we need to decarbonize. Solution, renewable energies. Renewable energies, and in my opinion, solar energy, for one reason. Because solar energy is the only energy that, in my opinion, is democratic. The sun reaches everyone. wind, geothermal are important, but we need some specific characteristics. Sun is useful for everyone. So I believe that this kind of alliance in the next future must be involved mature and mature, bigger and bigger and forth to send this message. We need to believe in renewable energy and to invest in this direction. And the best ambassador, in my opinion, is the youth. Younger generation, you have these capabilities to, first of all, you understand this immediately. It's easy to speak with you about this. You are involved in climate action, and you know how it is critical this moment and how it is important the widespread of renewable energies. Secondly, because we need to create a common consensus, moreover, common dialogue. This is the next step of the climate diplomacy, to put at the same table everyone. And believe me that right now, this is the real challenge, to put everyone at the same table, recognize what we have in common and not what is the difference among us. Because if we are able to recognize what we have in common, first of all, our planet, we can see the differences as a richness and not as a limit.
Wow, thank you. Thank you, Professor Corvaro, for that question. Because internally within ISA, when we think of solar and the knowledge and that sun is for everyone and the inclusivity part, I think the aspect that it is a democratized source of electricity, energy, and is for everyone, there forms a basis of our new vision, which is focusing on moving from ambition to action. But you also raised a very interesting point of you can't do it alone, right? You need the youth to come in, the policymakers, the academia, and all of that. Italy's geographic and diplomatic position gives it a very unique role as a connector to the whole of Europe. You know, between Europe's technological strength and the global South's urgent developmental priorities. What, in your view, is the leverage of Italy's role to act as a bridge between Europe and the global South to champion this partnership?
In my opinion, it's time to stop to speak about global South and global North, first of all, for a lot of reasons. But starting from climate, this is easier to explain and to understand. Yesterday, I had an event here with several younger people, and I tried to send them this message. One of my dreams is that through our youth, you can create a global alliance where it is possible to put at the same table Ukraine younger people and Russian younger people, Israel younger people, Palestine younger people, to send a message. Before of everything, it's time to think about our future. And our future is connected to our planet. And I believe that you want a sustainable future for you and for your son. So if we are not able to discuss about this, which is the meaning of the COP? Do you think that it's really possible to solve the problem in a closed room, dark room, speaking about negotiations? So I am optimistic because I am an engineer. So I know very well that we have all the technologies that is necessary to fight against this crisis. Moreover, these technologies can be an opportunity, and I told you, particular for the younger generation. Which is the gap? The gap is that we are not disposed to speak sometimes. I want to give you this example. In my first mission in Kenya, I participated to a big meeting, and after each meeting, there is the family picture. And I put myself in front of the camera, but immediately I recognized that my colleagues from the Europe side stayed in another and looking me between curious and strange. And I didn't understand why, because in my opinion, I was in the right side because the camera was in front of me. But looking close to me, I see the Russian Federation. So I know that from a diplomatic point of view, there is messages. But first of all, I am not a political man. I am not a diplomatic. I am a scientist. And I believe that I need to speak with everyone. And I believe that this kind of alliance is good to speak. In New Delhi, someone asked to the DG, which is your position about the possibility that China enters or not. In my opinion, it is necessary to have China, to have Russia, to have everyone. Otherwise, we are losing only time. And we need the COP 31, 32, 33, 35. For this reason, we are trying to use Italy as a bridge. Think about the Mattei Plan. The main purpose is to demonstrate that it's possible to create a bridge between global north and global south to pass these differences. Create dialogue is the only way, at least in the climate issue. And moreover, I want to his dream that starting from climate, we could also probably solve some other divisions. But again, we need to create the dialogue and to decide together, because the fight against the climate is not a race to arrive first, but it is a race to arrive together.
Thank you, Professor Corvaro. But, you know, we also operate, the youth of today is looking for real action. And while there are bridges that we could make to connect to a lot of places, we still need to look at reviving the spirit of multilateralism. And somewhere over the course of these 10 years, there is a growing trust deficit that has come into this particular thing. And then the youth are looking up to it. You know, the difference between the words and the action, the finance and delivery. From your vantage point, how do we restore this confidence that a multilateral process works and it is much larger than resolving just the tons of CO2?
Fortunately, speaking about climate, because I am the climate envoy, multilateralism approach is the only possibility. We don't have any other solution. It is necessary to be very clear on this point. We can have several possibilities in some other field, G2G approach, B2B approach, what you want. In climate, it's not possible. Not because I am saying this, but because as scientist, I know very well that climate respects physical law. Translation from diplomatic point of view, no borders in climate issues. So, or we accept this and we act at the multilateralism level, or we don't see any really result. Tomorrow, Italy will become net zero. And then nothing changed. Europe became, India became, is something that must be involved everyone. But right now, we have a crisis in the multilateralism approach. This is evident. For this reason, I want to come back to the youth role. because we need new minds in comparison to the one that right now has the duty to solve the system. We need new perspective. We need to be brave in this moment. It's not easy, I know very well. I risked a lot of time that someone said me, okay, go in another place, please. Because sometimes what I am saying is not so acceptable in some rooms. But fortunately, I have another job. So if they decided to fire me, I came back to my university with young people, and it's a good job. It's not a bad job. So I have the possibility to speak clearly and frankly, because right now we need to change. And this can be possible only throughout the younger generation that are ready. Then it is possible to find some illuminated people at the political level. Not so much, but it's possible, in my opinion. But we need to give them the force, the support, because one thing that impressed me very much, I participated to an event organized by NATO in Montreal, and there was a panel on the information around climate. And I discovered, with my surprise, that there is a sort of misinformation on not information that try to give you this message. If you are interested in climate crisis, you are alone. This is the, they are trying to inculcate in you this message that if you are interested in this, you are a minority part. Reality is the opposite. And obviously it's the opposite. Because if your house is under attack, obviously you are interested in this. And this is what is happening. Be careful. I want to avoid any confusion. Climate crisis is not the end of the world, because planet is able to surpass everyone. I give you this message. Some scientists found a mushroom that instead of using the chlorophyll synthesis that normally is the tree, they use radiation, nuclear radiation. For them, Chernobyl is the paradise. You can't enter in Chernobyl area, but for them is the paradise. Nature is able to find the way every time. The problem is, in this new balance, which is the position of the human life? Because this is the problem of climate change. The issue is for us, because we are really connected with the nature. But normally, thanks to the technology, thanks to the artificial intelligence that are good, obviously, we forgot. And we think that we are God, like God. We are not in this position. And we need to recognize and to remember this when we want to speak about climate crisis for us, not for the climate. Right now we have 450 parts per million of CO2. But in the ancient year, a lot of million years ago, we arrived to 1,000. So it's not an issue for the planet, but it's for us. But we need to rebuild this. We need to rebuild the trust in this. And I believe that one of the possibilities is to invest in this kind of alliance that look for the purpose and not for the other things.
Thank you, Professor Corvaro. And I think three things that you said resonate a lot with us at ISA as well. One, the importance of new perspectives, the importance of the fact that nature will find a way. It's not alarming for the planet, it is alarming for us. And number three is making action-oriented vehicles. I'll also invite everybody to look around. Some of our work is here designed completely on action-oriented things. But let me now draw your attention to the fact that when we move from all of the pledges and perspective to actual possibilities, looking at the developmental priorities that some of the developing countries have, finance is a key issue. Now, today where we sit at this intersection of geopolitics, innovation, and climate change, the financial structure has to evolve or has to be rethought radically. What, in your opinion, is the new global climate finance architecture? Is it more of just a blended finance instrument, or is it just guarantees, climate for debt swaps? What do you think is needed to accelerate this aspect?
So I think, first of all, that if you are not ready to invest right now in the transitioning, you are stupid. This is not something, I am not an economist, but I am able to see the price, the system, the costs. Right now, to give you an example, the cheapest possibility that we have to produce electricity is through our renewable energies. So why don't we invest in this? Or you are stupid, or you have some other reason. So again, the problem is not in the technology or in this or in this. Because another thing that I try to explain to my politician is this. Climate crisis is happening. In the next 5, 10 years, it's difficult to say. We have the opportunity to use climate as an investment. After that period, climate is only a cost. Translation, you have to pay in any case. Okay, but this is acceptable only if you have a vision. If you are not looking for the voters of tomorrow, but for the world of your son and your grandson. This is the difference between a statist man, a man that has a vision, instead that a man that wants to earn something immediately. Which is the purpose? It's easy because the number is numbers. You can see the report of IRENA, you can see the report of the International Energy Agency. Everyone is evident that right now it is possible to, if we are speaking about investment, is here, is clear. Put money to have back money. The cost, you put money and finish there. So it seems stupid, but I understood that the problem is that they are not stupid. They are looking for something else, some interest, some other problem, some other idea behind of this. So we are in a situation that we don't have enough money to answer to climate crisis, climate investment, and so on. We need to change the class that are now at the level of the dirigent level. I am sorry in this, but it's evident. For me, it's evident. The first time that I entered in one of these kind of rooms, I remain surprised because the situation is like this. You say that this is black, you say that this is white, and seems that you are right. Every one of you is right. It's not possible. Or is black or is white. But this is the normal, call this narrative. You see this? The narrative is this. And if we, normally I have the opportunity to participate again and again, the same speeches. So I believe that it is really important to change the narrative. To change the narrative, it is possible only if we change minds. For this reason, I like one of your projects very much, that is the StarSeed Center. This is the key. The key is invest in new minds, in new capabilities that can have the opportunity, because at the end, some of these young people have the opportunity to arrive to a minister level. This is the key. Change for there, because we are the majority, even if they try to give the message that we are a minority part. I don't find any other solution, because science is clear and this, under this point of view. The number of invest in the solar energy is clear. They think that the fossil fuel is something that it was in the past. It's true that in the past, Italy used a lot of fossil fuel and increased the pollution. It's true. But in 1950 was the best technology. Now it's not the best technology. It's clear. In my house, I have a big solar panel, not because I am green, because it's convenient. It's easy. If you take the bills, use a simple calculator. You can use also by hand. It's not necessary the calculators. At the end of the day, you can immediately recognize that it's convenient. What is else? What is necessary mucher than this?
No, and I think what you make as two very important points is that the financial sector will cost every aspect. And the greater the risks, they will cost every aspect of the risk as well. But you also bring in the perspective of a culture change and the change of the minds and perspectives, for which you have interesting tools and incentives to draw, behavior change that way. Let me now have a question around the CBAM. And do you see that as a catalyst to promote more RE, or it is a constraint for the global South? Because, there is a debate that goes on. So I thought I'll ask your perspective on this.
Again, it depends. If you use, the question is correct, but normally it's not possible to answer to a question with another question. But sorry, if you have the CBAM, you are able to obtain money. In which way you want to use this money? Because the problem is this. Because I can accept this narrative if this money is useful to invest, to support the developing countries to achieve a better sustainable way to transportation. This is possible. But if you want to earn this money to invest in fossil fuel, it's not the solution. Again, we have to, the instrument in itself is not bad or good. It depends to the use that I want to do with these instruments. If this instrument can be useful for investment in the emerging economy, to support them, for example, for new biofuel, to reduce the impact of the ship transportation, or for hydrogen, or this could be a possibility. Otherwise, it's not useful, not for only for the global South, but also for the global North. It's something that is a limit and not a possibility. I saw a possibility only if the purpose is the same, to achieve a sustainable future under an environmental, economical, and social point of view. Only in this way we can achieve really what is the purposes of the Paris Agreement. Otherwise, is another another element that is a limit, a constraint for everyone, for the commercial, for the globalization, for everything. So it is necessary to understand the purpose of this and how this can be useful for the emerging economy that needs support for sure. First of all, because for the vulnerability. Second one, because normally the developed countries are the first line in the climate crisis.
Professor Corvaro, I have had such a pleasure hosting you for this, but before we end this, let me pose this last question to you. COP30, in the heart of the Amazon, a COP being positioned as the COP of implementation. What would success at the end of these 2 weeks look like from your perspective?
First of all, for me, the first success happened already because we are here. We are here to discuss. We are here to have a confront. All the countries are here except someone. But this is the first example that we are alive, first of all. Second one of the best thing of this COP is really to improve the implementation. But from my point of view, the implementation is possible only throughout this kind of alliance, like the ISAL alliance, that put on the ground what is written in the paper of the COP. Because COP is able to write paper, to say we should do this and that, but then we need to translate this on the ground. And I saw a lot of projects that you are following that has this purpose. Because the president of COP, Dolago, said that we want to be a COP for the implementation. This is true. We spoke a lot in the past. Now we need to find a way to implement what we wrote in the past COP, because we know very well what is necessary. We need to mobilize money, and Italy in this case believe. I want to give you this example. Mattei Plan, nobody knows this, but which is the real positive aspect, in my opinion, of the Mattei Plan? To put together public and private sector is the only way. We need to cooperate together. This COP must be clarified. If we are not able to involve everyone in this kind of discussion, it's not possible to achieve any kind of result. We can write a lot of things, we can repeat every time the same speeches, but we are not able to achieve any really good results.
Thank you, Professor Corvaro. Let me open the floor for any question or two, if anyone has that, please.
Yeah. Hello, everybody. I'm going by the name Ali Shauri. I'm from Tanzania, especially Zanzibar Islands. I'm here as a young who want to grow in climate, especially for the energy issues. And as you see now, we are in an energy transition. So as an energy transition, we have to see what the solution for the future. And I'm here at the solar hubs. I want to know the solar hubs or your movement, how African country has achieved in this. And as a young, I already built the interest to building my capacity and to raise the awareness in my community. And in your conversation, I see the way you respect the presence of youth and young people and the movement of solar issues. So how can I get the chance or opportunity to rise or to build my capacity and to raise the awareness where I'm from in Africa? Thank you.
Thanks for the question. I believe that the biggest possibility that you have, first of all, is to study and prepare yourself. You have several centers that is dedicated for this. Italy supported this because we believe that throughout the education, the formation, the information, you can reach you increase your capabilities and show you the capability of your community. Is a sort of virus that pass man by man, women by women. So this is really important. And after that, doing that, I believe that it is possible to attract more interest, private money to invest, because Africa is the most richness continent. You have a lot of great opportunity, great richness, great resources. So the only way is that Italy need to share with you the knowledge, and we are ready to do this. We are prepared to do this, but to give you the possibility to be independent. And I want to add one important thing. One of the most used words right now is resilience. Throughout the renewable energies, you have the capability to be resilient. Also, in the very bad situation of war, because if you have renewable energies, you are independent from anyone. And energy right now is the first brick for your future. Without energy, it's not possible to do nothing.
Thank you, Professor Corvaro. And that I'm afraid this is all the time we have. I had a pleasure hosting you. So, ladies and gentlemen, Professor Corvaro.
It's a pleasure for
thank
me
you very
every
much.
time. First of all, because I saw so younger people. You have, as Steve Jobs said, be foolish, be hungry. Is really important right now. Stay foolish, stay hungry. And right now, for the future, it is important to be dedicated to this kind of discussions. Thank you. Thank you. Every time but we have another event.
Hello, good afternoon to everybody. So we are starting now a panel discussion here on a really critically important issue for COP30, that is net zero at COP30. And the panel is visualizing net zero economies to inform actions. So the point is, there is no most important issue here at COP than to know how to achieve net zero for different countries, for different economies, and for the good of the society as a whole. So basically, this is the main issue on this panel. We will have four important panelists. First, Erik Larsson, that's professor from Princeton University. We have Ajay Mathur, professor of IIT Delhi. We will have David Tsai from Instituto de Energia e Meio Ambiente. And you have Professor Tiandu Peng from Tsinghua University. So basically, we will have an initial discussion followed by some moderators, and then we open the discussion for the whole public. So basically, Erik is recommending that if you want, you can use these fonts because it could improve because it's too noisy here. But anyway, so I will pass straight the word for Erik for his presentation.
Thank you very much, Paulo. Can people hear me? It's okay. You can use this if you want to hear better. I'll stand up. Can we start the slides? So my name is Erik Larsson, and I, with colleagues at Princeton University a few years ago, I led a big study called Net Zero America, which was quite impactful, quite influential in changing policy in the United States at the time of the Biden administration. Unfortunately, we've gone back since then, but the project itself demonstrated the power of the approach that we were using for informing action. And so let me tell you a little bit about that project. And then what happened as a result of that is that other countries came to speak with us and say, we'd like to do something like this in our countries. We think it could be quite important. And so we've started collaborating with colleagues here and others to develop similar studies in these countries. And those are still ongoing. And you'll hear about those from India, from China, and from Brazil today. So the idea broadly is to be very open and transparent about the modeling that is done for decarbonization and do the modeling in such a way that it actually informs policy formulation and decision making. So next slide, please. Is it possible to remove that? Thank you. So this is an overview of the study. It was 9 different institutions collaborating, 18 researchers. It took us about 2 years. You can click on the QR code to get the study. It's about 350 pages with mostly graphics, very little in the way of words, because we wanted to be able to communicate effectively. So what we started with was a sort of coarse resolution optimization modeling, state-of-the-art models to say, what does the energy system in the country need to look like? Thank you. In order to reach a net zero target by 2050 for the United States. And then we did what is the most, I think the most important part of the work was what we call downscaling, which is visualizing what that coarse resolution modeling looks like at very fine resolution. And I'll show you some examples of that. But by doing this downscaling, it lets us unpack the implications for the transition of things that people care about land use, about infrastructure development, about capital requirements, jobs, health, and air pollution impacts. And so we generated a lot of maps and a lot of visually informative material. And then we took that, and unlike, I think, many academic studies, we spent a lot of time engaging with stakeholders so that they understood both how we did what we did, as well as what the results showed. And ultimately, the study was quite influential, as I mentioned. So let me give you just a couple of snapshots of the some of the results that we generated. This is a example of the solar and wind electricity generation that would be required in the United States to get to net zero by 2050. On the left-hand side, you see solar and wind farms. And what I'm showing there is the annual rate of construction that would be needed under 3 different scenarios. We looked at different scenarios because different stakeholders have different visions about what the future should look like. And under any of the 3 scenarios we're showing there, we would have to be building much faster than we were at the time in the United States, both solar and wind. So that's sort of an aggregate view. It's hard to really understand what that means for most people. But if you look on the right-hand side, this is a map that was developed at a resolution of about 5 kilometers as to where could you build the solar farms and where could you build the wind farms. And we mapped this at 5-year time steps so you could see how the landscape is changing over time. And it's this type of mapping that was quite visually informative, and that's what I mean by the downscaling work that we did. And there we go. And we also modeled employment related to the energy transition, which of course most people care about is jobs. And what this shows is the state by state in the United States from 2020 to 2050, the change in employment related to the energy transition by different resource sector. And what this shows overall a very positive picture in one perspective. There are many more jobs in the energy economy with this transition. On the other hand, it's also a challenge to to find those workers to do those jobs because most in the US at the time, we have virtually full employment. So it lets you think about where are the jobs, what are the impacts locally. And in some states, there are job losses because they are fossil fuel dependent states. And again, that helps to sharpen the focus of policy to help support those communities that might not fare. And we also looked at air pollution, again, and health impacts from air pollution. And I won't go into the details, but this was done at a county by county resolution. And the most important changes in air pollution are the reduction of coal-fired power plants and the transition from gasoline internal combustion engine vehicles to electric vehicles. And you can see the picture is very positive for air pollution with the transition. So those are just a few snapshots out of the 350 pages of the report. So feel free to look in more detail. But this is sort of the timeline of the progression that went from our Net Zero America study to what we call our Net Zero X initiative, where X is China or Brazil or India or other countries. We published our report as the Biden administration was taking office. And then we did very extensive engagement with decision makers and stakeholders. My colleagues and I gave on the order of 300 briefings to Congress, to the executive branch, to private companies, to non-governmental organizations, all of the stakeholders that need to be participating in the conversation about the transition. And we also got some pretty good media attention, including international attention, which then gave us the idea that, let's see if we can do something like this with other partners in other countries. And so that led to the Net Zero X initiative. And all of the Net Zero X studies are led by local teams. Princeton is collaborating, but supporting in ways that we have some comparative advantage. But obviously, the studies need to be led locally. And this is the current map of where we are collaborating and some of the future countries we think would be quite important to engage. We're also, and these are major projects. This is a 2 to 3 year effort at a minimum, and with related resources to back that. And we are planning to have a first workshop of our global energy modeling decision support community next fall in Princeton. Just a couple of quick, more detailed slides on the modeling approach. And it's a bit different in each country, so you'll hear about some of the details, but overall, there's the three models in blue here, an energy demand model. What are the services that we want from energy going forward? And what are the technologies that we will use to try to meet those? And that generates a set of final energy demands that need to be supplied. And we have the dark blue modeling set called the energy supply optimization. And that is the modeling that we do at core scale combined with land use and land use change modeling. And that middle one is especially important in Brazil, but also in other countries. And then that modeling set communicates the results to the downscaling effort, where we use a variety of different approaches to visualize, again, at politically and socially relevant scales, what the future looks like. And then in the pink box in the middle, we make a very concerted effort to be very transparent about both how the work is done and what the results are saying and all of the assumptions that go into it. And this is really important to be able to sort of democratize the conversation with stakeholders. And as well, some kind of a web-based stakeholder engagement tool. This will differ from one country to the next, but that's an important way to get a broader engagement. And then, of course, just concerted stakeholder engagement. I think I'll skip this in because I want to leave time for others to give some comments, and I think I'll close with that. So thank you.
Thank you very much, Eric. Very, very nice presentation.
showing that if you have a comprehensive models that can be easily adapted for other countries, it will be a major step forward in the decarbonization of our society. So now I will pass the word to Ajay, who will provide examples for another important country in the world, that is India. Oh, sorry. Let's go for, sorry for my mistake. Let's go for Tiandu Peng. Also to talk about a critically important country, that is China.
Oh, hello. Okay, thank you. I'm Tiandu Peng from China, an associate professor at the Tsinghua University, and our pavilion is nearby. Yeah. Okay, so today I will give a brief introduction about the Net Zero China project. Professor Eric Larsen has given a detailed introduction about the framework of Net Zero X, including the targets, also the framework of modeling work, and also the whole framework of the Net Zero X coordinating from different countries. So today, for China, we utilize the same framework of the modeling framework. And today I will introduce how will China team to build this modeling and how to simulate the future of China's net zero target. So for the name today is exploring pathway towards China's net zero future. Sorry. We know that China has announced the carbon target to achieve the carbon neutrality by 2060. And also China has a near-term and a middle-term target for the carbon emissions. For example, for China announced that it will achieve carbon peaking by 2030. And also there are some target for the installation of solar and wind and renewables. We know that for the new NDC announced about 1 month ago, China commits that China will, by 2035, China will reduce the economic-wide greenhouse gas emissions by about 7 to 10 points compared to the peak level. That means that there was not only for the carbon emissions, but also for the greenhouse gas emissions. And China also have a target for the installation of the renewables by 2035. Let's move forward to the future. China announced that it will achieve the carbon neutrality target by 2060. We know that this is the target for the carbon emissions or greenhouse gas emissions, but what is the pathway? And which approach will be cost effective and will be affordable for the whole society? This is very important. So our work was to explore the future pathways towards the carbon emission, the carbon neutrality target. And here we just simulated the carbon target by 2060, but our model can simulate it different carbon target year. For example, we can simulate the carbon neutrality target year in 2050 or 2070. It's okay. But here we focus on 2060. Okay. So what will our future energy system look like? Why we focus on energy system? This is because that almost 80% of the CO2 emissions are from the energy system. And this, for our human activities, most of the CO2 emissions are also from the energy sector. So for our phase 1 project, we focus on the energy system. So for the energy system, if we want to explore the future transition pathway or the decarbonization approach for this sector, we should know 4 things. First one was the service demand. So this is because that all the energy will be utilized for our life, for our mobility, for our buildings. So we should know what the service demand will be. This is the first thing. Second thing was that if we want to meet the service demand in the future, so how much final energy we should produce. So this is the second thing. For the third thing was that where are the primary energy come from? we know that for the final energy demand for the mobility, for the building sector, we need electricity, we need hydrogen, we need gasoline. So where are they from? From renewables or from fossil energy? So this is very important. This is third thing. The fourth thing was the downscaling. Just like what Eric said that for the future, we need a huge investment. Where will this investment to be? This is important. So we should know the infrastructure, the facilities. Also, we should know a very high resolution for the future infrastructure and the facilities for the whole energy system. So this is the four things for our modeling work in the phase one. So I would give a brief introduction about the different part of these four things. The first one was the demand side. Just as Eric said that we will utilize the energy pathway model to analyze the future service demand and the final energy demand for China to achieve the carbon target goals. First, we should know what is the demand side. Always for our modelers, we use to separate the whole energy system as a supply side and the demand side. Demand side means that we are energy consumer. There will be many energy consumptions. Supply side means that that will supply the primary energy and convert the primary energy to a final energy. So for example, the power sector and the renewables. For demand side, it means that here we just focus on the building sector, transportation sector, and the industrial sector. We know that in United States or in Europe, transportation sector will be the largest CO2 emitter sector. But in China, industrial sector shares about I think about half of the CO2 emissions for the demand side. So this is very important in China. So in our model, the industrial sector will be a very important sector for us. For each sector, for example, for building sector, we will separate, there will be about 6 subsectors. For example, heating, cooling, lighting, and special heating. So for the transportation sector, there will be more than 10 subsectors. For example, the passenger vehicle, the freight vehicles, also two wheels, and subways, railways, and aviation. So for the industrial sector, we know that China owns I think the largest capacity for the manufacturing. So here there will be about 40 subsectors. For example, the food, beverage, also clothes, and iron, steel, and aluminum. So about 40 subsectors. For all these subsectors, we will utilize energy pathways to analyze the future service demand and analyze the future final energy demand. Another very important thing is that first, we should know the long-term demand for our service and energy. We should know the annually or hourly demand. This is because that demand side, the energy demand side, for example, for the power sector, this is important for the supply side. For example, the supply side not only need to meet the long-term balance of the demand and supply, but also need to meet the balance hourly. For example, for the power, there are the flexibilities for the system. So we should know the energy demand in an hourly level or annual level. So this is very important. So we should know the load curve for the consumers. Second sector was the supply sector based on the macro model. And this is a very comprehensive and very complex model that has been built by Princeton University. But now we are doing the localization work to build the macro China model. For this model, that the demand side model will be an input. For example, the demand side will provide the parameters for the risk demand of different final energy, for example, for power, and also for other fields. So the model, the macro model, will simulate the whole supply side based on cost effective. For example, how to achieve this system based on the most cost effective ways. And also we should know the storage, the pipeline, the network for this system. Another important thing, just like Eric said, that not only the energy are very important, also what will happen for the energy system will impact the social economics. For example, the employment, the GDP growth, also the air pollution. So this is also very important issues for China. So based on this supply side model, we also will analyze the future air pollutions, the future employment, and the future the future economic growth based on this supply side model. But also this will couple with the supply the demand side. The third important thing is about the affluent sector, agriculture, forest, and land use. This can be seen as a demand side and supply side because it is a energy consumption sector because energy will be utilized, for example, for the agriculture, also for the forest. Also, the forest will supply the biomass and it's a carbon sink. So we should know, so how many biomass feedstock can be supplied from this sector and what was the carbon emissions from this sector. So this is very important for the whole system. And the other thing, another very important thing was the storyline. So the storyline for the future. We know that the scenario analysis is a very important tool for us to know or to analyze the future map of our life. So for our model now in the phase 1, we just set three core scenarios, three main scenarios. All these three scenarios, the key assumption for is that electrification will be the key approach for the demand side. But for the supply side, we have three different approaches. For example, for the reference, it means that the energy system development under the current policy, for example, the carbon peaking policy and the China 1+N policy system. For the E+ scenario, it means that renewables rollout rate almost unconstrained. Also, for the E+ with AI, we know that AI will be very important in our life, not only in demand side, but also in supply side. It will improve the energy efficiency, but it will increase the energy demand. So this is the key scenarios for net zero China, but also for the E+ scenario, also have three sub-scenarios. This is because that if for the future power supply, maybe renewable may be the most important one. But if we consider the energy security, we consider the the stable supply for the renewables, maybe nuclear and fossil energy will also play a very important role in the future energy system. So we consider three sub-scenarios to analyze what will happen. For example, full renewables, always part of nuclear, always part of coal or natural gas. So this is the basic scenario analysis. Yeah. So the last important thing was the downscaling. This is what I said before, and Eric said that we should know where will be the facilities and where will be the infrastructures. So this is important not only for the policymakers, but also for the financial and the investment. So currently we have to do this work on a provincial level, but in the future we will move this provincial level to the high resolution. For example, 5 kilometers or 10 kilometers. This is very important. So the last thing we'll introduce our team. This is the phase 1 for China, Net Zero China team. The researchers and the advisors are from, for example, energy sectors, policies, also AFLU, and also from, for example, environment sectors. So this is for phase 1. And in the future, maybe more and more researchers will join us because that we know net zero is a huge and complex work for all of us. So thank you. This is a brief introduction. Yeah.
Thank you very much for this very comprehensive approach to change the energy system in China. It's very, very impressive. So now let's see the example of India, another critically important country.
Thank you very much. It was a pleasure to be part of this global study. And I must confess that while I am not a part of the actual study group, I have the honor of chairing the advisory committee for this project, and so know a little more about it than I would otherwise. So first of all, why did we do this? When we look at, so India's announced that we will go net zero by 2070. That's what the goal is, which means that the electricity sector becomes net zero by 2050 or 2060. We can achieve it. However, what it does mean is that the many issues related to the sustainable development goals, particularly those related to jobs, particularly those related to air quality, remain unfulfilled. That is the way where we are going now. The second thing that we did was to look at the kinds of mitigation pathways that we have to reach the net zero, the kinds of developmental outcomes it can have, and I'll come into the differences between the mitigation pathway and the development pathway. They could be different, but hopefully they could be the same as well. What are the kinds of trade-offs that result in this, whether you get more jobs, whether you get more mitigation, whether you get more air pollution or less air pollution? And what are the kinds of policy levers, particularly those related to, for example, the allocation of technology or capital that will lead to these kinds of outcomes? So with the modeling framework we used was something very similar to what has been used by China and by the US, where we first looked at the demand, and our partners in this are the Priyas Energy Group, hence the Priyas Integrated Energy System, the PIER. And then what happens is we disaggregate it, because it does depend the land issue. As we will come to in a moment, land turns out to be the major constraint, and therefore what are the kinds of trade-offs associated with land will come as the next step, and hence the downscaling of it into bite-sized pieces that we can handle becomes important. Finally, what are the kinds of skills needed? And therefore a survey of the workforce, both of today as well as of tomorrow, and of the kinds of places that are available, particularly, and this is an important issue, particularly where biodiversity is concerned. Not that long ago, there was a particular bird, the great Indian bustard, which is found in the northwest part of India, that was under threat. And consequently, the Supreme Court put 1 million square kilometers out of this renewables area. They said you can have renewables, but no overhead lines, it'll have to be underground lines. That makes it very expensive. And therefore, the key issue became, how do you manage the trade-off between land on the one side and biodiversity on the other? Yet another trade-off that came out. So what we've looked at are 3 scenarios. And these 3 scenarios on the fact that, one, we go all the way on mitigation. In other words, ensure that the goals are. The second, that we go on development, ensure that the sustainable development goals are achieved. And which I said, hopefully will come together in the systematic view. Now, I am relatively simple-minded, and therefore to me, the way these things were different, what was the cost of delivered energy? If the cost of delivered energy was less than the cost of fossil fuel-based energy, then it became synergistic. If it did not, then it went the development way. If you kept high prices, but you forced the investment into renewables, well, that became the mitigation pathway. So these are the 3 systems-based scenarios that we are looking at. This obviously has a lot of stakeholders involved. We developed an advisory group which consists of the various parts of the group, but also the stakeholders, and consequently use this as a sounding board in whatever we do. So one of the issues that happened was that if you notice that the greatest energy demand increase is in the residential sector and to some extent in the industry sector. This is important because what it tells us is that these are the areas where growth is occurring and will continue to occur. This therefore tells of both the technology interventions that are needed as well as the kinds of investment decisions and the nudges that are needed in order to move from the current technology base to the new technology base. So looking at all of this, the answer was very, very clear. As I said earlier, the true trade-off is in land versus renewable. So today what happens is that when renewables are built, the renewable developer and the owner of the land get into one-to-one agreements. This leads to all kinds of problems and is also the reason why the formal upscaling is not occurring. The upscaling essentially occurs when there is a government push. This is despite the fact that last year in 2024, we found prices of round-the-clock electricity, renewable electricity, solar plus wind plus storage, which were less than the cost of coal-based electricity. And price and things that were formed, renewables and coal that came into existence at the same time in 2024. Yet we see that upscaling is a problem. And as I said earlier, the upscaling is because of land, which is the largest problem, but also because it takes 4 years to build a transmission line, as opposed to 2 years that it takes to build a renewable energy plant. And even though the cost of electricity is less for solar plus wind plus storage, the problem is that the investment cost is almost double. And if the investment cost is double, it means that at scale, you need to find more investment money. Okay, so now we looked at where is it that we can locate this, taking into account the siting issues and taking into account the investment issues. So this tells you of the areas in which it is possible. So solar, wind, and we looked also at the land costs in these as proxies of the value that people associate with land. And it tells you that the places where, for example, solar is done, if you can get the state to be involved in establishing the kinds of contracts, the people would be happy to provide land at costs that are competitive. On the other hand, what we also looked at was the transmission costs. And here the challenge becomes, how do you make sure that you've got adequate capacity of transmission lines from the places where you've got the development of renewable energy occurring? Because it makes no sense to have a separate line for solar, a separate line for wind, and a separate line for batteries, because each of them works with a capacity utilization factor of 30%. On the other hand, if you can locate it all together, then you've got a capacity factor of 90%, which makes the line a lot more viable than it would be otherwise. So as we look to the future, we are looking at about, approximately this time next year at the next COP, we should be able to present the deep dives that we're talking about the spectral resolution and talking about the sectoral views on how the demand will develop. We will also be ready with the kinds of challenges, both in terms of employment and in terms of the air pollution, the kinds of skills development that would be needed. The final report and the briefings associated with it would occur after that. So we look forward to getting together with you next year when we discuss these in greater detail. Thank you very much.
Thank you very much, Professor Ajay, for this comprehensive plan. So now we'd like to invite Davi to discuss about the Brazilian implementation of this model.
Hello all, thank you. My name is Davi or David. I'm project manager at the Institute for Energy and the Environment. And I'm here representing a lot of institutions that are involved in this project, in this initiative in Brazil. So we have a set of 4 think tanks or NGOs. There are experts in monitoring emissions and have done some work on projecting emissions on prescriptive scenarios for zero carbon trajectory. And we are also co-leading this initiative with the University of Campinas, Unicamp, and universities abroad, Instituto Dom Luiz, University of Lisboa, the Princeton University, and University of Minnesota. So we are still at the early stages in Brazil. We have started this project 6 months ago, but we're very excited for 3 reasons. So the first reason is that we can contribute to the to the small community in Brazil that we have for modeling zero emission pathways. So we have the group working in Rio, Universidade Federal do Rio de Janeiro, with Professor Schaffer, that has been working closely with the Brazilian government in proposing the Brazilian trajectories. And they have proposed a net zero trajectory for 2050. Also in the Climate Observatory, the 4 organizations are part of the Climate Observatory. We have proposed a prescriptive scenario for net zero in 2045. And most recently, we have Professor Carlos Nobre and others proposing a net zero for 2040. So we're very excited in this project, as the other countries have shown, we can analyze different scenarios for different timeframes. The second reason we're excited is to be part of this network, so we can use the very front science of modeling. And the third is that we truly believe that visualizing in the territory the downscaling is key to put into action what the models are showing us. And in Brazil, we have 3 challenges that are different from the other countries that I would like to highlight. So in Brazil, we have land use and agriculture as a really big chunk of the emissions. So we have 42% of emissions in Brazil due to deforestation today. We have 30% of emissions due to agriculture, mainly because of cattle raising. And that's a very hard to abate sector because it's very widespread into farms. And the energy sector only accounts for 20% of emissions. And besides that, we also have a huge opportunity of lying within restoration of lands. We have a mandate of restoring 20 million hectares of land that was degraded. And currently, the current regeneration of vegetation already accounts for an offset of 30%. So we have a 30% offset in carbon removals from the atmosphere from land restoration. And that certainly can play a huge role in the future if Brazil pursues the zero deforestation policy and also works on more forest recovery. So that's why the land use change team is very big and it's like the same size as the energy and industry and waste team. So next one, where do I point? Okay. So we're still in the initial stages, and one of the challenges is how to integrate all of the sectoral models. So land use change, agriculture, and energy. And currently we are working with the MAGPIE model from Potsdam, where we will have as output coarse scale land use according to scenarios for food production, GDP growth, and also climate change. And that will be downscaled using the SEALS model, calibrated by Mapbiomas, which is a Brazilian land use monitoring platform that gives, by analyzing satellite data, Mapbiomas classifies the territory within 30 meters per 30 meters squares pixels. We have the classification of the land. And for the energy sector, we will basically follow what the other countries are also doing, following the energy demand model using energy pathways and optimization model using macro. But here we also have the challenge to integrate macro into SEALS, because we will have to have a very integrated vision on land use, since we will have to, at the same time, comply with our restoration objectives, our zero deforestation. Biofuels should play a very important role, and that demands land, and solar power that also demands land. So that integration will be key for our modeling in Brazil. We are lucky to have Tasso on our advisory board, who has put us the last challenge after all of these technical challenges, that is to build a tool that will give full transparency for the modeling and allow anyone to play with scenarios, and so that other proposals of trajectories can be compared in the same framework. And next one. Okay, thank you. So just to give you some very quick, very preliminary results, not real results on, they haven't been reviewed yet, but just we are learning how to operate the models. So we have run the downscaling for the land use change using the SEALS model calibrated by Mapbiomas data. And what we are able to do now is to produce a map of land use classes on a 300-meter scale. So while MAGPIE gives us the land use at 0.5 degrees, which is roughly 100 kilometers, we are downscaling it to 300 meters. And the goal is to have it by 30 meters. So it will be pretty accurate if we can reach that goal. For the energy sector, we have modeled the transportation sector using feeding the energy pathways with previous models that the teams already had worked on the past. As I said, bioenergy will play definitely, it's challenging because we are such a big country. We are dealing with different geographies, different vocation areas for different crops. And we have the issue of seasonality of the plantations. So this is a great improvement that we will have to be taken into account by developing upon the macro model. And some last preliminary results that we have is what will feed into the macro system is the candidate areas for solar system. So in this map, you can see the levelized cost of energy for solar according to the potential of solar incidence and distance to the current existing infrastructure of transmission and distribution. So this is just an example that will be fed into the macro modeling. And also we will have one of these for wind and biofuels and so on. So we wish that by the first semester, we have the first round of reviewed results that can be shared publicly. And for next COP, we wish that we will have the first version of the tool, then that we can, everybody can play with that and visualize the results. Thank you.
Thank you very much, Davi, for the plans for the Brazilian component. And now, at the dynamics of the panel, we will exchange the people here. And I would like to invite Mr. Suman Chandra.
She had to leave because
Oh, she left.
the Brazilian and the Indian negotiators are getting their heads together.
Okay, that's more important. Really nice. So I would like to invite Mr. Zhang, that is Vice President of Institute of Climate Change and Sustainable Development of Tsinghua University, Mr. Leandro Cardoso, that's the General Coordination of Department of Mitigation Policy and Implementation Instruments in the Brazilian Minister of Environment. So I think that the task now is you to provide your comments on what we heard about the three different exercises that are important for all our countries. Please.
Thank you so much, moderator. So you will speak together with me, right? Yeah, okay. So I'll keep my comments very brief. So first of all, I would like to thank Princeton University, particularly Professor Larson, for providing the fundamental modeling framework to the partners. I think that laid a very solid foundation for this very unique approach to work together. So this is extremely important. I think I also want to thank my colleagues from Tsinghua University from China, and of course from all the presenters from Brazil, from India, and from the US. You know, they have, especially my colleagues, I know that they have been working very hard over the past year and a half to enrich the platform, the modeling platform, and also by localizing and putting in country-specific data into the modeling so that we can have a truly global access and open source modeling system. So I think this is my first point. So the second point would be this is a modeling collaboration, but it's no longer, you know, it's not only a modeling. So I think it is a value added to the multilateralism that especially at the moment that we are facing the 10th anniversary of the Paris Agreement. And if you look at the past 10 years, we see the Paris Agreement is effective, is resilient, but it's also faced so many challenges, right? So I think this particular collaboration, this partnership, focusing on modeling, but also beyond the modeling, it's itself a great contribution to the Paris Agreement and to the multilateralism under the Paris Agreement. So this is my second point. And my final point is getting practical. if we look across the hall, it's another pavilion. It's the GEUC pavilion. We call the Global Alliance of Universities on Climate. So it's a university-led coalition, but it's run and operate primarily by young people, by students from 15 universities. We also have a very similar program we call, this is Net Zero X, right? So we have Climate X program for the students. So I think I will call for a collaboration between Net Zero X and Climate X. So this year, for example, Climate X is online educational program. It reached to universities in over 80 countries. And those students are extremely enthusiastic about climate change, but also relatively highly educated about the knowledge of climate change. So I think if we can bring the findings of this modeling collaboration into the course, for example, next year in July till October, we'll have the 2026 Climate X campaign program. So I will be very delighted to support this kind of a collaboration. So finally, I think at Tsinghua University, we are extremely committed to support this collaboration. And so we'll do whatever we can and do our best to promote this collaboration. So with that, I thank you for your attention. Yeah. Yes. That's okay. Hello. First, I would like to thank the Professor Stasio Azevedo, Eric Larson, David Tsai, Chandu Peng, Ajay, Mahur for the invitation, and greet my other colleagues in the panel. I'm very happy to see how the Net Zero initiative has evolved since we met last year in Princeton. As a public policy officer, myself, I will briefly comment the initiative from the perspective of how those models and the scientific evidence that they produce can be best used to inform climate policy decisions. Let me introduce, for those who doesn't know, the fact that the Brazilian second NDC submitted by Brazil to the new UNFCCC last year was informed by evidence produced by an integrated assessment model called Brazilian Land Use and Energy Systems, BLUES, which was created and developed by the University of Rio de Janeiro. The lessons that we learned from this process might be useful for you in the near future. First, the first lesson that we had was that an integrated assessment model can provide the big picture of mitigation trajectories, following the most cost-effective path to the whole economy, but its results must be contrasted or complemented by sectoral models which are more detailed and specialized in terms of technological costs and maturity than an integrated assessment model. In practice, this means that climate policy making process should encompass, at least in my viewpoint, two groups of evidence from the whole economy and sectoral detailed evidence. Secondly, defining premises and scenarios for the modeling exercises is perhaps the most important stage of this process. Moreover, the definition of those parameters must involve not only government officials and scientists, but also a broad range of stakeholders from civil society organizations to the private sector. And they must be broadly publicized and transparent. This consensus is extremely important because when the results come out, they must be the focus, not the premises and scenarios themselves. Going back and forth with that will cost more money and time from all of us. Thirdly, climate policies are essentially development policies, especially for developing countries such as Brazil, China, and India. Therefore, decision-making
will never be solely based on mitigation trajectories and ambition, but also have to be compatible with economic development and equity in the short and long terms. So those models must also be able to estimate socioeconomic impacts over time in GDP, investment, employment rates, interest rates, prices, trade balancing, among other economic variables. If they also encompass territorial specialized impacts at the local or macro-regional levels, such as the net zero model here presented by the professors, the better will be. That is a great achievement of the model because policymakers would be able to decide based on detailed territorial impacts and take action in order to minimize negative local or regional impacts or enhance positive impacts. Finally, the modeling process must present at the end a comprehensive results report, presenting not only the different results for different scenarios, but also the possible trade-offs between mitigation, ambition, and socioeconomic impacts. In this way, all stakeholders would have the information needed to inform their own perspective on which should be the path to be taken to reach its mitigation goals, especially the net zero goal, which in the Brazilian case is set up to happen in 2050. Also, policymakers will only make better informed decisions if they have the full picture on possible mitigation trajectories, related socioeconomic and territorial impacts, and their trade-offs. Thank you.
Thank you very much. So now it's time to open up. I will invite the partners back, the presenters back. So now I invite you to exchange pieces again. And then we will open up the discussions and questions and points for the audience on this very critically important issue. Please.
Thank you so much. I'm Catherine Jamvala with UNDP. And I was invited by Professor Larson here. We're sitting on the plane coming here from Sao Paulo and talked about it. And I said, of course, I'm going to come and listen because it's so interesting. My question was first about the policy, but I think the gentleman who just talked about the policy and the involvement of the policymakers in the process. I heard that for you, Professor Larson, once you did a lot of briefing also. And I saw in China that you, no, it was not China, it was Delhi, India. You had in your steering committee members of the government, but I didn't see that much in China. So I was wondering, to what extent are you planning to get the policymakers involved in the process? Are you going to wait until you have the results to present it to them? So I will want to know in China, what will be the role of the policymakers? My second question is about, to what extent can this be applied to adaptation? Or is it just like totally not suited for that? Thanks.
Okay, I think.
Me first?
Yeah.
Oh, thank you for your question. This is very important for us to, we know that our modern work, what is the role, what is the value for our modern work? Yeah, this is important. Currently, now this is in the initial stage. Now we just do the modeling work. How to conclude, how to include the policy, for example, implications is very important. And currently now in our scenario, first for the policy, we will try to break down the policy or target from the policymakers into our scenario to analyze how this policy will impact the future pathway. Second thing was that we hope to, from the result, to tell the policymakers whether this policy will be, suitable or be valuable for our energy system. So this is very important. But now it's difficult for me to tell you that how will this result will impact the policymakers. For I think for the second question, I think not for me.
Yeah, the second point was about adaptation. how these tools can help the countries to better adapt to the new climate.
Okay, for adaptation, to be honest, in our modern work now, we just consider the mitigation, the how to reduce the carbon emission. This is the most important thing for our research currently. But I think adaptation is important for us to analyze in our framework. For example, currently for the energy demand side, we will consider how will the extreme weather will impact the energy demand. For example, it's very hot, so the air conditioners will be utilized more frequently. This will impact the energy demand. And also, this will also impact the power grid. This is because the kilowatt, the peak power will increase. So adaptation, another important thing for the adaptation in our framework is that, for example, for the infrastructure, this will impact the output of the load curve of the PV. For example, because the extreme weather will impact the renewables. For example, the weather. How to adapt to this stream is important. In our current framework, we will set several parameters to reflect the adaptation. But I think maybe there will be many, there'll be more results, or be more implementations for the future for the adaptations. But currently, we focus on the mitigation. Thank you.
As far as adaptation is concerned, the kinds of challenges are very different. So this kind of a modeling effort would not work. So let me tell you, this is based on the example that we have of the impacts on the petroleum sector. So what we did was we looked at the kinds of impacts that there were, whether it was droughts or whether it was floods or whether it was cyclones. And we did a map of the country. And what we came out with was risk assessments. And therefore there is, just as you have tons of carbon on this side, you have risk assessments on the adaptation side. That's number one. Number two, yes, you need to bring in the policymakers early, because what it implies is two things. One is, it's not that more money is needed, but that money needs to be spent differently. And second, people need to be skilled differently in order to be able to do those kinds of risk assessments before taking on a project.
On the question of adaptation, I agree the optimization modeling is not appropriate, but the visualization at the level of downscale, that's the way I took your question, it's even more important in the case of adaptation. It's a good question. We haven't thought about how to do that, but it's related to risk assessment, as you said, Ajay. And there are folks who think about that, but it would be interesting to get a net zero adaptation project going or something.
Yeah, the issue of adaptation, even at discussions at COP, is very much delayed in terms of the mitigation. And you needed to keep up with adaptation, because we needed to adapt for last decade changes in climate change, and that's very nice you raise this issue. So, any other question?
If I can follow up on the, I noticed, I think from your presentation, you have health issues, right? Health consideration, like how climate change is damaging people's health. I think that is one of the adaptation goals under GCA, the global goals on adaptation. I think this COP will produce 100 indicators, which are measurable indicators. I think probably you already, it's not zero consideration, but I think if you have considered health into your modeling, then that's already part of adaptation efforts.
Yeah, really good. Yes. Well remembered. So thank you very much. It's time to move to other activities. Thank you very much for your presence in this very relevant.
Together.